Alright guys, welcome to this page of the notes. Now what we're going to do here on this page is I'm going to show you, I made a big deal of it in just the last video, that the order of matrix multiplication is very, very important. That if you reverse the order of matrix multiplication, that they're not going to be equal product matrix. There is no commutative property for matrix multiplication. So what I'm asking you to do is take a look and tell me, is matrix G times H equal to matrix H times G? Well, you already know the answer is no, but I don't want you to take my word for it. I'll show you. So we're going to go ahead and work through this problem. A couple of reasons. First, it's really good practice doing the matrix multiplication. It's not easy, and the more times we get to practice, the better we'll get at it. And second, you don't have to take my word for anything. I promise you, I'll always show you how it works. So that's what we're going to do. I tell you there's no commutative property. Let me show you. There is no commutative property for matrix multiplication. Here we go. I am going to do G times H. First, I need to make sure that I can do the matrix multiplication. I have a 2 by 3. 2 by 3. This is a 3 by 2. 2 by 3, 3 by 2. Those middle numbers, the 3's, they match. So yes, I can multiply these guys together. And let's go ahead and try it in our heads. Let's see if we can do this as mental math. I bet you we can. Here we go. 1 times 2 is a 2. 3 times a negative 2 is a negative 6. Minus 5 times 1 is a negative 5. So here's what I've got. I've got 2 minus 6 minus 5. Well, a negative 6 and a negative 5 is going to be a negative 11. You add 2 and you get a minus 9. 1 times 3 is 3. 3 times a negative 8 is going to be a minus 24. Minus 24. And negative 5 times 7 is going to be a minus 45. So here we go. I have a minus 24 and a minus 45. I add to that 3, and you get minus 56. Let's keep going. I got 4 times 2, which is going to be 8. Negative 2 times a negative 2, which is going to be 4. 8 plus 4 is 12. 0 times 1 is 0. So 12 plus 0, that's just a 12. 4 times 3, 12. Negative 2 times a negative 8 is going to be 16. So I got 12 and 16, which gives me 28. 0 times 7 is 0. 28 plus 0 is just 28. So there we go. I have my product matrix from doing G times H. What if I did H times G? Well, first let's figure out, is H times G even defined? Well, H is a 3 by 2 matrix, 3 by 2. G is a 2 by 3. 3 by 2, 2 by 3. The middle numbers, the 2's, they match. They're the same number. So yes, yeah, I can multiply H times G. The question is, what I get here, is it going to be the same as this? Again, we already know the answer is no, but I just want to prove it to you. So here we go. Let's do some mental math. 2 times 1. Wait, I'm sorry. Hold up. I apologize. You know what? Let me rewrite this. It's going to be 2, negative 2, 1, 3, negative 8, 7, multiplied by 1, 3, minus 5, 4, minus 2, and 0. All right, here's why I rewrote it. Because when I was doing G times H, they were already in the right order, row, column. Now that I'm switching them, I don't want it to be over complicated, because complicated enough we're trying to do these on our head, which is fantastic mental math, but we certainly want to take every step we can to make sure that we're able to do that math correctly. So by writing it now H times G, how does it work? Row 1, column 1. So here we go. 2 times 1 is 2. 3 times 4 is 12. 12 plus 2 would be 14. Well, already I can see that these matrices are not the same. I had a minus 9 in this one. Now I got a 14. So they're definitely not going to be equal. We have proved this idea that there is no commutative property for matrices. But let's keep going. We're not done. We can finish this up. Let's see here. I got 2 times 3 is 6. 3 times a negative 2 would be a negative 6, and 6 plus negative 6 is 0. 2 times a negative 5 is going to be a minus 10. 3 times 0 is 0. Minus 10 plus 0, minus 10. Awesome. Here we go. Let's keep going. Negative 2 times 1 is going to be a negative 2. Negative 8 times 4 is going to be a minus 32. I have a minus 2 and a negative 32, which gives me negative 36. Negative 2 times 3 is going to be a negative 6. Negative 8 times a negative 2 is going to be a positive 16. Negative 6 plus a positive 16 should be a positive 10. Keep going. Negative 2 times a negative 5 is going to be a positive 10. Negative 8 times 0 is 0. 10 plus 0, I get another 10. Yeah, awesome. Bottom row. 1 times 1 is 1. 7 times 4 is going to be 28. So we wind up with 1 plus 28 should be 29. 1 times 3 is 3. 7 times a negative 2 is a minus 14. 3 plus a minus 14 should be a negative 11. 1 times a minus 5 is going to be a minus 5. 7 times 0 is 0. And so negative 5 plus 0 would be minus 5. All right, there we go. That is my product matrix. Not only are the elements different, they're not even the same size. The product came out to be a 2 by 2 matrix. This product matrix came out to be a 3 by 3 matrix. So not only are they not equal, they're not even the same dimensions. And no, G times H does not equal H times G, which is exactly what they said. There is no commutative property for matrix multiplication. Guys, thank you so much for joining me for this set of video lessons. At this point, you should be comfortable with multiplying matrices and then the properties associated with matrix multiplication. Thanks for joining me. I had a great time. I'll see you the next time.